Hi, welcome to our Facebook page and YouTube channel Born in Soil. Today I discuss the topics set theory. Before discussing this theory, first we know the syllabus. First we discuss the syllabus JEE Mains. This section for the admission of B and B Tech, and such paper is called paper 1. The paper 1 contains the whole syllabus of mathematics and combining with physics and chemistry. So this paper for admission for different IITs and NITs and IITs. So first we write unit 1. This unit 1 contain set theory, functions, relation, and many other. So we first discuss today this theory, that means set theory, which contained in the JEE Mains syllabus. Next we discuss ISC syllabus. ISC syllabus contain 100 mark in mathematics for class 11, and this number divided into two parts. That means this number divided two parts, which is called one part section A. This part contain 80 marks and another section B or C. This part contain 20 marks. This part is compulsory for everyone for in class 11, and this part B or C, you can choose B or C, any one of this part. So total mark will be 100 for ISC mathematics class 11. And next CBSE class 11 mathematics contain total number of mark 100, and this number divided in two part, 80 plus 20. This number is theoretical part, and this is and project purpose. So we discussed this part. This part contains set theory, relation, functions, many other mathematical chapter. So we discuss later, and finally we say that WBCHSE, West Bengal Board Council Higher Secondary Education for class 11. Mathematics containing full marks, and this number divided two part, 80 plus 20. This part in theoretical part and this part and project purpose. So we will discuss this part only, and this syllabus is very same for ISC CBSE exam pattern. So here we discuss all the syllabus parallelly for CBSE, ISC, WBCHSE, and mainly JEE mains syllabus we focus now. So today our first lecture on set theory. Set theory is a mathematical branch which discover many part of numerical functions such sequence, probability, any other chapter which discuss about the set theory problem. Now we discuss some basic definition of set theory. First, set theory developing the man who is German mathematician George Cantor. This man first developed the set theory concept. We know in our daily life we proceed this set theory function. For such example, all the rivers of India, all the vowel of English alphabets, that is A, B, C, D, etc. These all are well defined. For such example, we say that very important note that set is a well defined collection of distinct object Z and elements. So this is the very important point. Set is a well defined collection of distinct objects and elements. So we say that all the river of India is a set. All the vowels of English alphabets, that is A, B, C, etc., is a set. So again we consider all. Sorry, here we write something mistake. That is A, I, O, U. This because this is vowel, only vowel. All the vowels of English alphabet, that is A, E, I, O, U. So we see that these are sets. Now Amazon is a river which does not belong to in India. So we cannot consider in the set of all river in India. So number one, sets and their representations. Sets and their representation. How to set define and their representation? So here you see that set in generally written in the form of capital letter of English alphabets and their elements written in small case letter. For example, we see that A, E, I, O, U. These are all the vowels of English alphabet. So these are small letter. So we say that these are element, and we say that this is the vowels of English alphabet. So we can define a particular set. E. Where A is in capital letter. So here we denote the set capital A, which is capital letter, and their elements are small letter A, E, I, O, U, and which is also belongs to the second bracket, and their little term is comma here, etc. And now sets are two type of set builder. One is tabular form, or it is called roster form, and another form is set builder forms. First we discuss this form. Here, suppose you consider a set X. Two, 4, 6, 8, 10, 12. Here you see that this set contains all the element of even number 2, 4, 6, 8, 10, 12. This form is called tabular form, and we write this set also in the form X is equal to X, such that X is an even number, X less than 40. This is the set builder form. Similar set. Here you see that X is equal to 2, 4, 6, 8, 10, 12. The set builder form X is equal to X such that X is an even number less than 40. This set and this set is a similar set. So we see that the set can be represented in two forms. One is tabular form, another form is set builder form. Next, such important sets are N. This is a set of natural numbers. Set of integers. Sets of all positive integers. Similarly, Z negative is a set of all negative integer. Q. Set of all rational number. Rational numbers. And R. This is a set of real numbers. So we see that here are different type of set representation. These sets are very important. Now we discuss next topics. Empty set. Empty set. First, we consider a set X is equal to such that all the students in your class. All the students in your class. So, first we consider this set X is equal to this, all the students in your class. First we go to the school and then enter in the room, we count all the students. So, here you see that this set contains an element. This set contains an element. That means this set is not empty set. We now consider another set X, Y. All the students studying both classes 11 and 12. We again enter the school and we cannot find any student which are simultaneously studying in class 11 and 12. That means set Y contains no element. We say that Y is an empty set. So the definition a set contains no elements, it is called empty sets. It is called empty set. Generally, we denote the empty set in the symbol phi. The symbol generally we denote the empty set in the symbol phi. Next, finite set and infinite set. First we define finite set. Before discussing the set theory, all the river of India. Here is that all the river of India. That means rivers are countable in India. So we say that this set is a finite set. Another example. Here I consider and set all the vowels of the English alphabet A, E, I, O, U, which are countable. That means the set is a finite set. Is a finite set. We consider another set B equal to 1, 3, 5, 7, 9, 11. This set is a finite set because we count the element of this set. So this is a finite set. We now consider a set X. One, two, three, four, this. We see that this is an element in the set 1, 2, 3, 4, 5, 6, So here we see that this set are not countable. That means this set contains infinitely many elements. So it is called an infinite set. And this set can be written in the form X such that X belongs to N. X is an element in the natural number set. So we count every element in the set, but not the whole set. So this set is called infinite set. This set is a Boulder form, set Boulder form. This set is also an infinite set because this set contains all the even number in the set of natural number. So this set also be an infinite set. So we say that definition: a set contain a finite number of elements is called a finite set. Otherwise it is called infinite set. Infinite set. Next, one example such A is in set which contain 1, 2, 3, 5, 7, 8. This is a finite set, and this set contains 4 elements. And finite set contains 4 elements, and this number and denoted by n of A. N of A equal to number of elements, that means 4. A set contains n elements, we can say that n of A equal to n. Okay, next. Subset. The next topic is subset. First, we consider a set X such that X all the student in your school, and we consider another set y, all the student in your class. So here you consider two sets. One set is X, which contain all the student in your school, and another set is Y, which contain all the student in your class. So that means we say that all the elements of Y belongs to X, because all the students are the students of in your school. So we say that every element in Y is an elements of X. That means we can write symbolically. Suppose is an element n belongs to Y, implies n belongs to X, and in generally we denote the symbol this, and this symbol used for subset. That means Y contained in X, and this symbol is called subset. So again we consider a set A and B. Suppose all the element of A does not belongs to B, then we can write symbolically A not a subset of B, A not a subset of B, and this subset, this symbol is called not a subset of B. That means all the element of A does not contain in B. So a definition: consider two set A and B. If every element in A is an elements of B, then we say that A is a subset of B. Symbolically we write a subset of if A does not belongs to, if every element of A does not contain in B, then we symbolically write A not a subset of B. This is the definition of subset. Next, equal set. here. This set and this set are said to be equal if they contain the same element and same number of element. Then we say that A and B are called equal set. So the definition of equal set, two set A and B are said to be equal set if they have the same element in their sets. So another way to define two equal set: if A subset of B and B subset of A, vice versa, we say that A equal to B. That means these two sets are called equal set. Next, what is an empty set? And this set is a subset of every subset. This is important notation. This phi is a subset of every set. Next we define power set. Suppose we consider a set A equal to 1, 3. We see that 1 is a set which is a subset of A because this belongs to in A. Again 3 is a subset. This is a set, and this set belongs to capital A. And we know every set is itself a subset. So 1, 3 is also a subset of A, and phi is an empty set is also a subset of A. So we defined another set. We said this is called P of A. A P of A is called a power set of A. So we can define the power set all the subset of A is called a power set of A. So a set A is called a power sets if it contain all the subset of A. So can you see that P of A is called the power set of A. Now N of PA That means power set contain what number of element? So we see that 1, 2, 3, 4, 4 elements. So n of p equal to 4. We write this equal to 2 square. In generally, a set which contain n element, then its power set contain number of element n of pa is equal to 2 to the power n. This is very important for previous problem in IIT JEE Mains and WBCHSE, ISC and another board exam. Next, universal set. A set contain all the set is called a universal set. For such example, we consider a set 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is an universal set. So this is the Venn diagram. This is Q. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2, 4, 6, 8, 10. B 1, 3, 5. So this is you. First we consider this set 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. This is a set A and B 1, 3, 5. This is so 1, 2, 3, 4, 5, 6, 7, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That means U is a universal set which contain all the elements 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and A is a set which contain all even number, that means 2, 4, 6, 8, 10, and B contain only 3 elements 1, 3, 5. Here you see that these two sets contain in U, and also these are the disjoint set. Disjoint set because these two sets A and B have no common element. Then say that these two sets A and B are called disjoint set if they have no common element. Next, union of two sets. We consider a set A equal to 1, 2, 3, 5, and B is another set 4, 5, 2, 9, 11. union of two set means here consider two set A and B. That means we construct another set. Suppose this set is called C. This set contains all the element of A and B and which does not occur simultaneously and also including the common element. So here we write 1, 2, 3, 5. This and this come here. So 1, 2, 3, 4. 4 is here. 5, 9, 11. So here you see that C contain all the element of the set A and B and also including the common element. This set is called the union of two set A and B. Generally C is equal to A union B. This symbol is called union. This symbol is called union. This is a set, suppose this is A and this is B. So here we see that this portion is the common portion of the two set. This area plus this area plus this area. That means this whole area belongs to the union of two set. So the definition. Union of two sets construct another sets which contain all the elements two sets A and B. Two sets A and B construct another set which contain all the element of A and A or B together. That means we write symbolically the set X is equal to X such that X belongs to A or X belongs to B. This set also written in the form A union B. X belongs to A or X belongs to B. This is called union of two set. Now we defined intersection of two set. Intersection of two set. So first you consider a set A equal to A I E O. This is a set of vowel number of English alphabet, and we consider another set B equal to A U C D. So intersection means the common element of these two sets. So here you see that this and this are two elements are common in this two set. So we construct another set C. We get A, comma. This is the set C is called the intersection of the two set A and B. Symbolically, we write the intersection A intersection B. This symbol is called intersection of the two set A and B. Now, this is the universal set. We consider the set X and A, and this is B, the common element. So this portion is the common area of these two set A and B. So we can write A intersection B is equal to X, such that X belongs to A and X belongs to B. So the definition. Intersection of two sets A and B is construct another set which are common part of A and B. So we write A intersection B. This is the inter symbol is equal to X, such that X belongs to A and X belongs to B. So this is the definition of intersection. Now next we define complements. Next we define complement. This is an universal set U. This set is called A. Suppose we consider a set A which contain in A. Then we define the complement. That means the set of the universal set U which does not contain the element of A. That means A dash is the symbol is equal to X, such that X does not belongs to X is an element, but X does not belongs to A. This is the complement of the set A. So again we define double complement. That means X, such that X belongs to A. That means this is equal to the set A. So double complement of A equal to A. This is the very important formula. Now we define some important formula. Number 1, A union A equal to A. A union phi equal to A. A intersection A equal to A. A intersection phi equal to A. part. A union B union C is equal to A union B union C, or A intersection B intersection C is equal to A intersection B intersection C. Here you see that associative law property, lower property fault. Next we define distribution law. Distribution law. This is very important. A union B intersection C. That means A union B intersection A union C, or A intersection B union C. We can write A intersection B union A intersection C. And another formula, this is called De Morgan's law. A union B and their complement equal to A intersection A complement intersection B. Right. Again, A intersection B to the complement A complement union B complement. These are very important for previous exam. Next, difference of two set. Difference of two set. We consider a set A equal to 1, 2, 3, 4, 5, 6, 7, 8, and we consider another set 2, 4, 3, 5. A minus B, which is the difference of the set A and B. So this set contains the element of A which does not belongs to in B. So this and this and this are the same. So this part I remove, only this and this written here. 1, 6, 7, 8. So the definition. Definition of two sets. Difference of two sets A and B is the set which contain in the element in A but not in B. So symbolically we write A minus B. That means X such that X belongs to A and X does not belongs to B. Also we know A minus B equal to A intersection B complement. So this is the basic theory of set theory problem, and this is the first class of set theory in class 11 for ISC, CBSE and WBCHSE board, and mainly JEE Mains syllabus oriented. So this is the first lecture, and my name is Noordin Ahmed, and the next lecture will be tomorrow or next day. So thank you very much, and please subscribe my YouTube channel and Facebook page Born in Soil. Thank you.